Hello students, welcome back. In this session, I would like to discuss properties of rational numbers. I hope you are very much familiar with closure, commutative, associative and distributive properties. Let's discuss these properties with respect to rational numbers over different arithmetic operations by considering simple examples. Let's get into details. Students, let's discuss the properties of rational numbers over arithmetic operations. First, look into closure property. As you know that according to closure property, when you perform any basic operation like addition, subtraction, multiplication or division, if the resultant is also a rational number, then we can say that particular operation is satisfying closure property. Let's see which all operation satisfies this property. First one, addition. Let's consider two irrational numbers. For example, 3 by 5 plus 2 by 5. The resulting number is 5 by 5, which is a rational number. So we can say that addition satisfies closure property. Let's look into subtraction. One example, 3 by 7 minus 2 by 7. The resulting number 1 by 7, this is also a rational number. So we can say that closure property is satisfied with respect to subtraction. Now let's look into multiplication. One example, 3 by 4 into 2 by 7. The resulting number is, you can cancel out 2 here, it's 3 by 14, which is a rational number. Let's look into division. One example, 1 by 2 divided by 3 by 5, which will be equals to 1 by 2 into 5 by 3, that is equals to 5 by 6. This is also a rational number, so we can say that closure property is satisfied. Let's look into one more example. Here it is 1 by 2 divided by 0, but any number divided by 0 is undefined. So we can say that division satisfies closure property with respect to non-zero rational numbers. So from above examples, we can conclude that addition, subtraction and multiplication satisfies closure property. Let's look into commutative property. First one is with respect to addition. Commutative property of addition is represented as, if a plus b is equals to b plus a, then we can say that commutative property is satisfied. Let's understand this by considering one example. 1 by 5 plus 2 by 5, it will be equals to 3 by 5. Now let's change the order, that is 2 by 5 plus 1 by 5. The resulting number is also 3 by 5. As these two are equal, we can say that addition satisfies commutative property. Let's look into subtraction. Subtraction commutative property is, if a minus b is equals to b minus a, then we can say that it is satisfied. Let's look into one example, 3 by 8 minus 5 by 8. The resulting number is minus 2 by 8. Let's change the order, 5 by 8 minus 3 by 8, which will be equals to 2 by 8. But these two are not equal, so we can say that it is not satisfied. Let's look into multiplication. If a into b is equals to b into a, then we can say that property is satisfied. One example, 1 by 2 into 3 by 2, which is equals to 3 by 4. Let's change the order, that is 3 by 2 into 1 by 2, that is also equals to 3 by 4. So multiplication satisfies commutative property. Let's look into division. A divided by b is equals to b divided by a, then we can say that it is satisfied. Let's look into an example. As you know that 2 is a rational number divided by 3, that is 2 by 3. Let's change the order, that is 3 divided by 2, that is equals to 3 by 2. But these two are not equal, so we can say that division is not satisfying commutative property. Students, let's look into associative property of rational numbers. First we will discuss with respect to addition, which is represented as a plus b plus c is equals to a plus b plus c. Let's consider one example. 1 by 2 plus 5 by 2 plus 3 by 2. As you know that first we have to solve which is there in parenthesis. So 1 by 2 plus 5 by 2 plus 3 by 2 is 8 by 2, which will be equals to 9 by 2. Let's consider right hand side, that is 1 by 2 plus 5 by 2 plus 3 by 2, which will be equals to 6 by 2 plus 3 by 2, that is also equals to 9 by 2. As these two are equal, we can say that addition satisfies associative property. Let's check with subtraction, which is represented as a minus of b minus c is equals to a minus b minus c. If it is satisfied, then we can say that subtraction satisfies associative property. One example, 3 by 4 minus 5 by 4 minus 7 by 4, which will be equals to 3 by 4. This is minus 2 by 4, so minus of minus plus 2 by 4, which will be equals to 5 by 4. Let's consider right hand side, 3 by 4 minus 5 by 4 minus 7 by 4. 3 by 4 minus 5 by 4 is minus 2 by 4 minus 7 by 4, which will be equals to minus 9 by 4. But these two are not equal. So we can say that subtraction is not satisfying associative property. Let's look into multiplication. As you know that in multiplication, order of the operands is not important. So we can say that multiplication satisfies associative property. Let's verify that by considering one example. 1 by 2 into 3 by 4 into 5 by 4, which will be equals to 1 by 2 into 15 by 16, that is equals to 15 by 32. Let's consider right hand side, 1 by 2 into 3 by 4, this whole multiplied with 5 by 4, which will be equals to 3 by 8 into 5 by 4, that is equals to 15 by 32. So these two are equal. We can say that multiplication satisfies associative property. Let's look into division, which is represented by if a divided by b divided by c is equals to a divided by b divided by c. Let's consider one example. As you know that 1 is a rational number, right? Divided by 2, this divided by 3, which will be equals to 1 divided by 2 by 3, or we can write it as 3 by 2. Let's consider right hand side, that is 1 divided by 2, this whole divided by 3, which will be equals to 1 by 2 divided by 3, or which is equals to 1 by 6. These two are not equal. So we can say that division is not satisfying associative property. Let's move on to distributive property. Now let's discuss a distributive property of rational numbers. Distributive property is represented as multiplication over addition, or we can state multiplication over subtraction. Let's look into multiplication over addition of distributive property. If a into b plus c is equals to a into b plus a into c, then we can say that it is satisfied. Let's consider one example. 1 by 2 into 3 by 4 plus 7 by 4. First solve which is there in parenthesis, which will be equals to 1 by 2 into 3 by 4 plus 7 by 4 is 10 divided by 4, that is equals to 10 divided by 8. Let's consider RHS. So 1 by 2 into 3 by 4 plus 1 by 2 into 7 by 4, which will be equals to 3 by 8 plus 7 by 8, that will be equals to 10 by 8. So these two are equal. We can say that distributive property of multiplication over addition is satisfied. In similar way, we can verify distributive property of multiplication over subtraction, which is represented as a into b minus c is equals to a into b minus a into c. Let's consider one example. 3 by 4 into 7 by 4 minus 8 by 4, which will be equals to 3 by 4 into minus 1 by 4, or we can write it as minus 3 by 16. Let's consider right hand side. that is 3 by 4 into 7 by 4 minus 3 by 4 into 8 by 4, which will be equals to 21 by 16 minus 24 by 16, that is equals to minus 3 by 16. So we can say that distributive property of multiplication over subtraction is satisfied. From above examples, we can conclude the following points. Rational numbers are closed under addition, multiplication and subtraction. Even rational numbers are also closed under division when the division is with respect to non-zero rational number. Second point is rational numbers satisfy commutative, associative and distributive properties for addition and multiplication. In next session, we will discuss these properties with respect to irrational numbers. Please feel free to provide your questions or feedback in comment section. Have a nice day.